the technology that ended the Middle Ages. It wasn't gunpowder. Imagine for a moment that you are a medieval knight in 1400, protected by armor that cost more than an entire village, commanding a castle that took decades to build. Your walls are 4 meters thick. Your moats are impassable. For 300 years, your lineage has dominated this region because your defenses were literally invincible. Now imagine waking up one morning in 1450 to discover that all of this, your armor, your castle, your entire way of life, has become obsolete overnight, not by law or decree, but by a machine that fits on a cart and makes the sound of thunder. History has a cruel way of turning kings into beggars and empires into ruins. But rarely has a single invention changed the world as dramatically as the one we'll explore today. Before we dive into this explosive revolution, tell me in the comments, have you ever visited a medieval castle? When you were there, could you imagine those walls being built specifically to withstand sieges that lasted years? Because today we're going to discover how this age of stone and iron was literally blown to pieces. This is the story of the weapon that didn't just change medieval warfare. It demolished the Middle Ages brick by brick and gave birth to the modern world. Prepare to discover how the roar of cannons echoed through the centuries and still resonates today. The Invincible Fortresses. To understand the revolutionary impact of the cannon, we must first comprehend what it destroyed. For centuries, medieval castles were not just fortified homes. They were the physical foundations of the entire feudal system. These imposing structures, with their stone walls 3 meters thick and towers rising 30 meters high, were practically indestructible. Medieval architecture was a science of survival, refined through centuries of warfare. Every element had a calculated defensive purpose. Walls were built at angles that deflected projectiles. Moats not only prevented advance but forced attackers to expose themselves to crossbow fire from arrow slits. Towers provided observation points and overlapping fields of fire that covered every meter of approach. Medieval castle design incorporated ingenious psychological tricks. Spiral staircases ascended clockwise, favoring right-handed defenders with swords. Doors were deliberately low to force attackers to bend over, making them vulnerable. Even steps had irregular heights to make invaders stumble in the dark. Medieval siege warfare was a slow and brutal science that could last years. Harlech Castle in Wales resisted for 7 years. Chateau Gaillard, Richard the Lionheart's impregnable fortress, took 8 months to fall, and that was considered exceptional speed. Catapults and trebuchets could hurl stones against walls for months, causing minimal damage. Battering rams needed to approach dangerously close to walls, exposed to devastating defender fire. But the true strength of castles lay not just in stone, it lay in the economics of medieval warfare. Maintaining a besieging army in the field for years cost fortunes. Disease decimated attackers more than battles. The logistics of feeding thousands of men far from home often forced abandonment of promising sieges. The arrival of thunder. Then, in the 14th century, something changed fundamentally. A new weapon began appearing on European battlefields, first as curiosity, then as terror. The cannon had arrived, and with it, the death of medieval warfare. Gunpowder technology had developed in China centuries earlier, but it was in Europe that it found its most devastating application. The first medieval cannons were crude and dangerous devices, forged iron tubes that exploded as often as they fired. Edinburgh's Mons Meg, forged in 1449, weighed 6 tons and fired 150-kilogram projectiles, but needed to cool for hours between shots. Sound was part of the psychological terror. The thunder of a cannon could be heard kilometers away, announcing a new age of warfare. Horses panicked, inexperienced soldiers fled, and even veterans experienced primitive fear before this artificial thunder. Contemporary chroniclers described the sound as the voice of the devil himself. The chemistry of destruction was relentless. Where trebuchets left small marks on stone after hundreds of shots, cannons created devastating holes with single projectiles. The concentrated kinetic force was dozens of times greater than any previous siege weapon. An iron cannonball striking a medieval wall at 400 meters per second released energy equivalent to hundreds of axes simultaneously. More importantly, cannons introduced a new variable to warfare: time. Sieges that previously took years could now be decided in weeks. This military acceleration changed not just tactics, but the entire political strategy of the era. 1453. The end of a world. The moment that symbolizes the end of the Middle Ages can be dated precisely, May 29, 1453. On this day, the indestructible walls of Constantinople, the city that had resisted 23 major sieges over 1,000 years, finally fell. And they fell not to the courage or numbers of attackers, but to the revolutionary firepower of Ottoman war machines. Mehmed II, the young Ottoman Sultan of only 21 years, had understood the potential of cannons better than any contemporary. He commissioned Vauban, a Hungarian engineer who had been rejected by the Byzantines for lack of resources, to create the largest siege weapon ever built. The result was a bronze monster, 8 meters long, that fired 600 kilogram stone projectiles at a distance of 1.6 kilometers. But Mehmed didn't rely on just one supercannon. He employed an entire revolution in military art, 69 cannons of various calibers, arranged in coordinated battery, operated by specialists from across Europe and Asia Minor. This was one of the first applications of coordinated mass artillery in history. Constantinople's walls represented the pinnacle of Byzantine defensive engineering. 3 concentric lines of fortifications, some over 5 meters thick, protected by a 20-meter wide moat filled with seawater. These defenses had repelled Arabs, Bulgarians, Russians, Crusaders, and countless other attackers. The bombardment lasted 53 days. Each morning, Ottoman cannons poured hundreds of projectiles against the ancient walls. Each night, Byzantine defenders worked frantically to repair damage with wood, stones, and even bales of wool. But the mathematics were inexorable. Destruction exceeded repair capacity. Pause here for a second. If you're finding this historical transformation as fascinating as I am, give this video a like now. It helps me know you want more content about how specific technologies change the course of human history. And tell me in the comments, which historic castle or fortification would you like me to explore in a future video? The race for adaptation. The fall of Constantinople sent shockwaves throughout Christian Europe. The news travelled through merchant networks, reaching Venice in just 18 days, impressive speed for the era. Suddenly, every noble, every king, every city-state realized that their medieval fortresses had become obsolete literally overnight. The initial response was architectural panic. Walls were desperately reinforced with compacted earth to absorb impacts. High towers were demolished to present fewer targets, a humiliating admission that medieval verticality had become a fatal vulnerability. The Château de Vincennes, near Paris, had its famous 50-meter tower deliberately reduced to avoid becoming an artillery target. But it quickly became clear that improvised repairs would not be sufficient. What was needed was a complete reimagining of fortification science. European engineers realized they needed not just to defend against cannons, but incorporate them into their own defensive strategies. The first revolution was economic. Building artillery-resistant fortifications required astronomical investments. The Fort de Salses, on the Franco-Spanish border, consumed the equivalent of 3 years of French royal revenue. These expenses forced political consolidation. Only centralized states could finance the new necessary defenses. The second revolution was social. The new fortifications required permanent garrisons of specialized artillerists, unlike medieval knights. These were technical professionals who needed constant training and regular wages. Feudalism, based on land obligations for military service, could not sustain these new military realities. The geometric revolution. The solution came through a revolutionary application of military mathematics that transformed warfare into exact science. Renaissance engineers, many of them also mathematicians and artists, realized that the dead zone problem created by circular bastions could be solved through pure geometry. The triangular bastion was a mathematical revelation applied. Its pointed shape allowed defenders to cover every meter of ground around the fortification. 2 adjacent bastions could provide deadly crossfire, creating overlapping fields of fire that made approach virtually suicidal for attackers. Francesco di Giorgio Martini, the Italian military genius, developed the first mathematical formulas for scientific fortifications around 1480. His calculations determined ideal angles, 60 degrees for bastions, 120 degrees for ravelins, optimal distances between fortifications, 400 metres by Nassy, the effective range of muskets, and even the ideal height of walls, 6 metres, high enough to prevent scaling, low enough to avoid easy targets. But engineers didn't stop at triangular bastions. They began experimenting with increasingly complex geometries that looked like mathematical equations built in stone. Ravelins, diamond-shaped fortifications positioned in front of main walls provided additional layers of defence. Counterguards protected the bastions themselves. Half-moons created additional fields of fire. Crowned works provided elevated artillery positions. Military geometry became an academic discipline. Universities began teaching mathematics applied to fortification. Treatises on military architecture became bestsellers of the era, circulating secretly among rival states as strategic intellectual property. The age of star fortresses. Star fortifications spread across Europe like an architectural epidemic, transforming not just the military landscape, but the very political geography of the continent. Between 1500 and 1700, practically every important city, every strategic frontier, every valuable port was redesigned according to the principles of the new military science. Fort Portange in the Netherlands exemplifies the geometric perfection of star fortresses. Its plan, viewed from above, reveals a 9-pointed star where every angle was mathematically calculated. Its low, sloped walls deflected cannon projectiles. Its angular points completely eliminated dead zones. Its triangular bastions provided ideal platforms for defensive artillery with 360-degree fields of fire. But more important than its shape was its revolutionary philosophy. Star fortresses didn't try to be impregnable like medieval castles. They tried to be deadly to attackers. Every element was designed not to prevent attacks, but to channel and destroy attackers through coordinated fields of fire. It was a fundamental shift from medieval passive defense to modern active defense. Building these fortresses required unprecedented military logistics. A single average star fortress needed 2 million tons of earth moved, 500,000 tons of cut and transported stone, and 50,000 tons of lead for pipes and projectiles. Fort Palmanova in northern Italy employed 30,000 workers for an entire decade. The economic impact was transformative. Fortified cities became industrial centres, developing weapons manufactories, iron foundries, and military support industries. The demand for military engineers created Europe's first technical schools. The need for precise maps drove advances in cartography and topography. Vauban and the perfection of military science. In the 17th century, the art of fortification found its definitive genius in Sébastien Leprestre de Vauban, the French military engineer who elevated defensive construction to the level of pure mathematical science. Vauban wasn't just a builder, he was a visionary who understood war as a complex mathematical system. Vauban revolutionized fortification through his understanding that static defenses were only part of a dynamic military system. He developed the concept of defense in depth, multiple lines of fortifications that forced attackers to conquer a series of increasingly difficult positions, each designed to maximize enemy casualties. His fortifications included technical innovations that anticipated modern military principles. Armoured casemates protected artillery from enemy counter-battery fire. Tunnel systems allowed secret movement of troops and ammunition. Underground reservoirs guaranteed potable water during prolonged sieges. Internal gardens provided fresh food for garrisons. But Vauban's true genius lay in his mathematical calculations. He developed formulas that could predict with scientific precision how much time, men, and resources would be necessary to conquer any of his fortifications. His memoirs contained detailed tables correlating garrison size, ammunition quantity, expected siege duration, and defensive success probabilities. The Vauban system was so effective, it changed the European geopolitical balance. France, protected by more than 100 Vauban fortresses along its borders, became practically invulnerable to land invasions. For the following 150 years, no enemy army managed to penetrate deeply into French territory, a strategic advantage that allowed France to dominate European politics. The science of fortress destruction. Paradoxically, Vauban also systematized the art of conquering fortifications. His scientific siege methods transformed fortress capture from uncertain adventure into calculable procedure. The Vauban system for sieges involved zigzag approaches that minimized exposure to defensive fire, precise artillery positioning to maximize structural damage, and detailed timetables for each siege phase. His manuals described exactly where to dig approach trenches, how to calculate firing angles for siege artillery, and even how many pounds of gunpowder were needed to blow up each type of wall. Vauban transformed sieges from operations that could last years into 6 to 8 week campaigns with predictable results. This systematization had profound consequences for European warfare conduct. Sieges became less devastating for civilian populations because they were faster. Commanders could plan campaigns with unprecedented precision. The cost of war became calculable, allowing states to budget military conflicts like engineering projects. The end of an era. For more than 3 centuries, artillery-based fortifications dominated the global military landscape. Star fortresses spread not just across Europe, but throughout the European colonial world. Cartagena de Indias in Colombia, San Juan in Puerto Rico, and Gali in Sri Lanka demonstrate how principles developed on European battlefields were adapted for tropical climates and specific colonial threats. But just as cannons had made medieval castles obsolete, a new technological revolution was destined to do the same to star fortresses. In the 19th century, 3 innovations converged to make traditional fortifications vulnerable: explosive shells that detonated after penetration, rifled artillery that multiplied precision and range, and smokeless powder that eliminated artillery's main disadvantage, revealing positions after firing. The American Civil War, 1861 to 1865, dramatically demonstrated the obsolescence of traditional fortifications. Fort Sumter, designed according to Vauban principles, was reduced to rubble in a matter of days. The siege of Vicksburg showed how modern artillery could make fortified positions unsustainable, not through direct destruction, but by making life inside fortifications impossible through constant bombardment. World War I definitively buried the era of traditional fortresses. Belgian forts, considered the world's most modern, fell in days to German artillery. The Maginot Line, the last attempt at linear fortification in the Vauban tradition, was simply bypassed. The era of fixed fortification had ended, replaced by mobility, camouflage, and dispersion. Technology as a force of history. From the impregnable medieval castle to the scientifically designed star fort, from the siege catapult to the devastating cannon, the evolution of military fortifications reveals profound truths about how technology shapes entire civilizations. A single invention, the cannon, didn't just change how wars were fought. It literally demolished the physical foundations of the Middle Ages. The cannon made obsolete not just castles, but the very economic and social foundations of feudalism. When fortresses became vulnerable, the power of feudal lords based on fortified territorial control became precarious. The need for expensive artillery and professional garrisons consolidated power in the hands of centralized states that could mobilize resources on a national scale. The military revolution initiated by cannons established patterns that define our era to this day, accelerated technological innovation, planned obsolescence of military systems, and the constant need for adaptation or extinction. The Middle Ages had been characterized by centuries of relative technological stability. Swords, armor, and castles remained essentially unchanged for 500 years. But the modern era would be defined by the constant and accelerated cycle of innovation, adaptation, and obsolescence. This lesson resonates powerfully in our digital age. Just as feudal lords, who refused to adapt their fortifications, were swept away by history, organizations and individuals who cannot adapt to technological change face obsolescence. The history of fortifications teaches us that there is no permanent security, only constant adaptation. From the walls of Constantinople to Vauban's bastions, from gunpowder to explosive shells, we see how technology is not merely a tool of history, it is an autonomous force that shapes civilizations, topples empires, and creates entirely new worlds. The echo of those first cannons still resonates today, each technological innovation carrying within it the potential to transform our reality as dramatically as gunpowder transformed medieval Europe. So which of these technological revolutions do you think had the greatest impact on shaping the modern world? And more importantly, what current technology do you think is destined to cause an equally dramatic transformation in our future? Let us know in the comments. I love reading your reflections on how the past illuminates our present. Thank you for joining us on this explosive journey through military history. If you enjoyed discovering how a single technology can topple entire civilizations and give birth to new eras, give this video a like and subscribe for more explorations of the technological forces that have secretly shaped our world. Until next time, keep questioning official narratives and keep exploring the true forces that move history.